Hey, my name is Kuba and I'm a performance engineer. Today I'll be looking at Perfana, a tool for performance engineers and for continuous performance engineering. So let's get started. Now, this video is not sponsored by them. They've reached out to me to have a look at the product and to give some feedback. So I'm just sharing with you my insights and how much value this tool really brings to the table when you want to shift left and when you want to move to continuous performance testing. But first, maybe I'm going to talk about my own workload and how I do performance testing and how do I do troubleshooting. The chances are, if you are running a test in a pipeline, when you run lots of the tests, they will bring you very little value comparing to the ones that you actually look into, right? And this is the main thing that was holding me back to actually move to continuous performance testing, because I knew myself that I'm spending just as much time analyzing the test run as its duration. So I was actually spending my time looking into all the details that I could find from the application while the test was running. So I was actually spending more time on analyzing the test results and the test runs than actually running the test. So bringing the more tests to the table, bringing more test results and more test reports to the table only had introduced more workload on my side, because I had to spend just as much time analyzing those problems. And eventually they brought me to a bottleneck when I was spending more time on digging through all of the details than actually producing the reports, and the test results were just stacking up, and the technical depth introduced by that was never reduced, right? So you could run as many tests as you wanted, but a technical depth introduced, a few releases back or a few versions back, they were not addressed at the first sight, right? So it was still accumulating. So there's very little space and very little value added by just running the test continuously. Right, so just adding the test to the pipeline was not good enough. So I have listed a few steps that were actually a part of my test planning and execution, and then up to the reporting. The first step of each test, it has to be planning. The test needs to have an objective, and these objectives needs to be quantifiable. It can be a response time, it can be the maximum throughput of your application. This can be the hardware cost, hardware utilization of your application under similar load. These are all valuable objectives for you, right? So you need a plan of your test. What do you actually want to test and what do you want to see from the test result? Then you develop your test. There are certain tools, and there's plenty of tools right now that's going to convert your sessions so you can record your web traffic over some proxy and then have your correlations on it. This part has been well addressed in the past by the load testing vendors, because this is a great selling point for them. So if you have a load testing tool that lets you start testing, with a very little effort, that's already a gain. The next part is the test execution. And this is where you have to pay attention. When you develop your tests, you cannot bring any dependencies that require any manual effort from you. This means if you have a test that has some data dependency, that needs certain steps for your application, these all have to be automated. Otherwise, you would not even think about moving your test into the pipeline, because if you have to change this one attribute there, or you have to load this data somewhere in a database, or you have to take some database snapshot before every test, these all steps have to be automated in order for you to actually run your tests into the pipeline. Otherwise, you're still going to require some folk to go ahead and and do some manual work there. If you need more users for your application, you also have to load them from upfront. So these all have to be automated, and you need to make sure that all the dependencies, whether it be data, code, or configuration, they are brought in automatically. Otherwise, your test will end up being flaky. And that's the last thing you want, because you need a compatible result if you want to run them on a pipeline, so that the comparison of the two runs is actually meaningful. Otherwise, you will run up actually troubleshooting your tests more than your application. And that's the worst result you can have, because you're only adding up your workload to your test development. And this usually means that the test was developed wrong way from the beginning. Then after you have resolved the dependencies, there comes the execution part. And this is the simplest part ever, because if you have your test scenarios prepared well, and if you have your data prepared, it all comes down to just clicking a button. Right nowadays, the load testing tools, they are fairly optimized for that. So you just click a button, everything happens like automatically. This is a no-brainer. One of the prerequisites for that is that you simply can't let the test execution be constrained to some UI of yours. So you need to prepare your test to be automated over some CLI in order to successfully run them into a pipeline, because you will be moving them to your Jenkins, you're going to move into the GitHub Actions, to the Bamboo plans, whatever tool you want, but it's important to actually have them automated as well. And the next part is the analysis. And I know that the vendors like to brag on how advanced their analysis module is. The problem with the load testing tools is they only have the visibility over the end user. That's of course a lot in itself, but it doesn't show what exactly went wrong on the application. So in the end, even with the fanciest analysis module, you still had to go to your APM, you still had to go to your logs to see what exactly went wrong, and you ended up taking some snapshots, taking some screenshots of those screens, and compiling them into a single report. So this still required manual effort, not to mention even the checks like, hey, how was the CPU comparing to the previous test run, right? This was always a manual work and always required the attention from the performance tester to actually deliver a report of value. And if you had lots of data points there, it was easy to miss important details, and it was easy to make a mistake copying over some data. Like one of the workflows I like to do when I see a degradation in the response times, or I can see some problems in the particular test run, is that I want to look back into the previous test. So I want to compare what exactly happened in my previous run, and also check the last healthy run that I have determined that is actually a good run that I had in the past. So in order to do that for me, with, for example, having a blog aggregation tool, having an APM, having a load test report, is I have to go through all the three tools to check what actually went wrong, to do the comparison of the three. And if you have 3 data sources and 3 test runs, this gives you a combination of 9 data sources you're looking at concurrently to see what exactly went wrong. It gets even worse if you have to look at the application and and some stack and build the dashboard for you to do this comparison. This has never been easy. And if you have to look at 3 of them at once, this can be a mess, and you can miss a lot of details when comparing the 3. So it's very easy to miss important details when you have to look at 9 different data source points for you to make a decision and make a conscious comparison of what happened actually over time, right? You have to determine what has changed over time, like in the application. You have to see what exactly was the hotspot for your test run, what has changed in the code, how did it affect the single transaction, how did it affect the overall volumes, like whether there are periodical dips in your test run. And all of these are the steps you have to take in order to do the comparison and analysis of your test run. This, if you have to jump in between those, will easily become a bottleneck once you have more than a single problem, right? If you have, for example, multiple points where you want to troubleshoot and you want to see what exactly went wrong, you want to be thorough in your analysis, right? Especially when you have a challenging environment and we have a 0 error budget, when you have a 0 timeout budget, you want to make sure that all of them are flowing successfully. There's a lot of things you have to look into before you can actually submit a report out of it, right? Because people want to know, hey, what went wrong? What has changed? How do I fix that? These are the 3 questions you have to ask yourself and address them before actually submitting the report that you want to create. And this is why I was hesitant to bring in this continuous performance testing into my table, because I knew that it's not easy to streamline these activities and to push them, because I knew that the effort of bringing the automated test to the pipeline was not that hard, but the analysis that comes with that was. And I could not just concurrently do everything because I knew that the effort I had to put in for analyzing a single test run was far too great for me to have any benefit for that. And I think that the Perfana guys, they actually understand the problem. So let's look at the application and see what they have to offer. So I want to look at the compatibility and how many tools and which tools I can use with Perfana. It seems like they support Gatling, JMeter, LoadRunner, WireMock, which I've never used, and K6. For logging and tracing, they have listed here Elastic, Jaeger, and Dynatrace. For the Jaeger, I think they've replaced it already with Tempo. What I want to mention here is that this list here is a list of tools they support out of the box, but actually the only constraint here for their load test support is you need to be able to plot it in Grafana. So even if you have like a bash script, loading some files, loading some messages on a message queue, if you can plot it somehow in the Grafana, I think it should also support that. So the first thing you'll learn to appreciate with Perfana is the accessibility of the data and having it in a single place. And I'm going to show you what I mean here. So I have here a single test run that I want to see the report on. And you can see here it has all the details from both the application side. So I can see the details from my application as well as the details from my load test tool, right? So the JMeter data has been forwarded also to Perfana, to a Grafana engine, and then it's been plotted here and used by Perfana. This is by far the most advanced JMeter report I have seen. So you have all the details, all of the summary, all the response times plotted. And if you go here to the performance overview, you can even go to specific transaction type and see the full details of each of the calls, right? So, and this is a live graph. So once the test is running, you can already see the details. You can see the distribution of the load, the heat map, what's the errors per second. You can even see the raw data as the test is running. So that's pretty cool. The amount of effort it costs to really do a meaningful reports and meaningful graphs for a load testing tool, that's a lot. So that's not an easy task, and it looks like Perfana does it even better than I have with my previous videos, which I think technically makes them my competition. Now, if you are an Opentelemetry user, you are going to love this. Once you have found slow calls coming from your test, the next thing you want to do is to see the traces of those calls. And Perfana is integrated with a Tempo, so you can easily search for your transaction that had failed. The way it works, you are sending a baggage over headers to your application, and then the application uses this baggage as the attribute for your spans. So you can easily search for specific traces inside your Tempo using those attributes. These are the transaction name and the test run. So if you, for example, want to see the traces of my slow calls, I can just go here, and Perfana is going to search for the traces available, and I can search for specific traces of any slow transactions. So if I click here, it's going to give me the details of potentially error or slow calls. This means you can instantly search for any problems or errors inside your Tempo. Talking about DevOps, we can't really talk about it without mentioning the SLIs. And Perfana has a way to do that. So as you can see here, it's not restricted to just your load testing tool and load test report. You can also specify your SLIs based on the charts and graphs from Grafana you specify. So this can be some state of a database, this can be some state of your application, this can be a connection pool. Anything you want here can be specified as an SLI. So you just add a metric here, get the dashboard you want to get from. For example, I want my failure rate to be less than 5%. So I'm just gonna go here, specify the metric I want to have. So I'll check percentage fail requests, and on average I want it to be less than 5%, right? It also lets you to compare a percentage or positive negative values with some deviation. Let's say I'll add a 50% deviation here comparing to the previous test runs and the baseline. And this little checkbox here, this already tells me that Perfana knows what they're doing. It is a common problem that the ramp up is also included in the test when it shouldn't. So the ramp up itself serves the purpose of warming up the services, of warming up the cache and loading the details and the data that would already be warmed up by the application. Because if we specify the window of our test, it is typically before and after some load. It is just a small subset of what is going to happen during the day, right? So chances are, if it's not a load after full restart, if you don't want to simulate the cold start of your test, you typically don't want the ramp up to be included in your measurements. Otherwise, for example, if your ramp up is 10 minutes and your load test is 2 hours, your P95 will already be skewed because of that, because that 5% is going to fit into this 10-minute window that you are warming up your request. Of course, it's your decision to include this in the report or not, but still, this decision has to be conscious. Otherwise, you may be presenting bad results just because you are testing the wrong thing. So adding up a feature of excluding the ramp up here, I think it's a great solution. And you can specify the regex pattern for the series. So if you have a multiple series in this dashboard, you can specify exactly the type of transaction, for example, you want to apply this to. Otherwise, it will be applied to all. So I had this thing running for a week now, and I got to play around with it, run some tests. There was a demo application there that I could use with all the features included. And here are the checks and the validations that I found most useful that were coming straight from Perfana. And that's the stuff you would normally have to go and check, right? The first one that really blew my mind was an invalidation of a test itself. So you can see here, it gives you the reasons why the test has been invalidated. And this one was because my test duration was less than 60 seconds, right? And it was a complete misfire from my side of the test. I had to stop it, and then Perfana picked it up as an invalid test. So that's pretty cool. So whenever someone looks into your test results, okay, this test looks invalid, and it gives you the exact reason why. I think more conditions that I saw tests being invalidated were due to lack of data. So if you have some SLIs and checks you want to have compared, if the test run doesn't have this data, it's gonna invalidate your test as well. Another level of checks I wanted to show you was the report that I saw, and normally it would have been tagged as okay by most of the tools. But what you see here is that I have passed all these service level objectives, but compared to my baseline test, I have deviated, right? So you can see here an increase of various percentages, like even up to 32 times for a single transaction. And this gives you a full overview what exactly happened, right? And you can compare this comparing to the previous test run. And even though you have passed the SLAs, you can have those validations applied to your test data and to your charts to figure out the regression of your system performance. And that's very impressive comparing to available tools on the market. Another cool feature is the comparison. So if you go to configuration tab, you can also compare the configuration of both your test and your application. So as long as you supply this information to Perfana, it can run a diff of certain configuration items you're supplying. And in this case, for example, I have a configuration of the test that I was running with some parameters, and I did change one comparing to some previous test runs. And if I run a diff here, it's going to show me exactly what has changed over time. So if the regression of your application performance is caused by a configuration change, you can also run a diff here to see what exactly had changed between the versions. And that's pretty cool. This is exactly the stuff I'm normally doing myself when I go to the application configuration and I want to see the factors that may be affecting the component or a feature I'm currently troubleshooting. Now, reporting in Perfana is extremely easy and almost instant. Because it's running on Grafana engine and because it has all the details of the test runs and all the details of the application and the load testing tool, you can easily compile them into a single test report, right? So I'm going to persist my report here. So you can specify your own reporting template and the details you want to see on the report. They don't have to be your SLIs, but they can be a summary of your test runs, and you can easily persist them and have them here. So, these are easily shareable with everyone. So if you have a test report, you can add a description, you can add some summary here, and that's extremely useful because the report creation is instant. You don't have to go through all these places, gather the logs, gather the information, gather the errors from the application. Everything is already in one place, and that's what I think is the Perfana superpower. Now, another extremely useful feature are the trends, but not just the trends from all the test runs, because you can compare the same test runs of the same workload. This means you can compare your stress test with a stress test, you can compare your load test with all the load tests, and also the baselines against your baselines. That's extremely helpful because if you just run a baseline based on the utilization of your environment, your result will be different. To mitigate that, Perfana does a grouping of your workloads for the load test for you to make a comparable trend. And let's see how it works. So you have a trend here, and here are your SLIs. So you get to specify which SLI you want. It just doesn't have to be your load test data. You can add any value here. For example, I'm going to look at the spans of my application. So I'm going to look at the spans from tempo. And you can see here the distribution and the change of behavior of this particular span over time. And it points me to the test version that I'm interested in. So it points here to the version of the application. So I can easily compare the change or the trend between the application versions and my test runs. That's extremely useful because then you can trace back the change of the application that had affected the performance of your service. So that's another great feature here. So I see Perfana as a great productivity booster if you have a small team managing multiple applications, running many tests, or simply running them in a pipeline. Now, Perfana is not an open source tool, it's a commercial product, but it lines up perfectly with open source load testing tools and helps you get finally some meaningful results and actionable reports. Automating the comparison and checks and validations really helps you take the most out of your test runs, because if you simply put your tests in a pipeline, chances are you will not get more value from that, and you will simply lose money on all the infrastructure you're using for your tests and for your application. Taking advantage of Grafana as a data visualization is also a smart move because it boosts the compatibility with all the frameworks, and most of them do support to some extent export of data and live plotting in Grafana. So it greatly introduces the chance of compatibility of your application with Perfana. And having the data from your load test side by side with the application saturation and the application state really helps you understand what exactly happened on the application side and how it affected your end user. This may not seem much, but telling a story of how the end user was impacted by your application is not easy, and having it shown on a single page and on a single screen is very helpful for everyone to understand exactly the root cause of the problem. Automation of checks and validations minimizes the risk of any errors in your reports and also minimizes the risk of missing important details like increasing CPU or increasing the hardware utilization in general. But also relying on those automated checks will introduce you to more workload on fine-tuning and tweaking the alerts. This is a domain of proactive performance testing. You may end up with too many false negatives, and if you have too many of them and too many alerts that are not actually the problem, you'll end up either not looking at them at all or just disabling them. So it's important to remember that these checks and validations serve the purpose of saving you the effort of checking it manually every single time, and you have to reevaluate whether you actually need those or not. So overall, I do love the tool, and of course I am biased because I was going to implement the same thing myself, but it checks really all the boxes that I could think of for me to get a productive test runs and not only focus on the end result, but also on the improvements and how the application has changed over time, and to get the insights of what should be improved first and what would be the plan for any performance improvements or efficiency improvements. Because that's also important, not just the end result, but maybe the application can be running faster, but we don't know what to change and what to target. I think Perfana lets you do that by automating the stuff that should have been automated anyways and letting you focus on the good stuff and focusing on recommendations and deep dive into the application behavior. So let me know what you think. If there's any other tool I should be looking at and maybe you're interested in a review of, just let me know and I may look at it. And thank you for watching.